Hello, I'm Jessicat, and today I want to do a very different format of video. Today I want to talk about a math problem known as the Monty Hall problem. Now this problem, the Monty Hall problem, comes from an old TV show where the host of the show was called Monty Hall. And this show was based on the idea that there are three mysterious doors, and these doors each have something behind them. One of them has something very desirable behind it, say a diamond block. The other two, however, have something that's really not so desirable behind them, say a lever. Now, of course, I want the diamond block, but I have no idea which door it is behind. So the way this works is I will pick a door. Let's say in this case I want to pick door number 1. Now that I've made my choice, Monty Hall will go ahead and open one of the other two doors, one of the ones that I haven't chosen. Let's say he picks door number 3. He will open that one, and you can see that there's a lever behind this door. There is always going to be a lever behind the door that Monty Hall opens, and this is because if you pick a door with a lever behind it, he will open the other door with a lever, and if you pick the door with the diamond block, he will simply pick one of the two. So either way, you're going to get a lever behind whichever door he opens. And now you have a choice. You can either stick with your first choice or switch to the other door. And the question is there a way to make sure that you have the best possible chance of winning? Well, actually, the answer to that question is yes. And I'm going to explain why in Minecraft. Now, let's say that I've picked this first door here. The chances of the diamond block being behind the first door are 1 in 3. We can agree on that, right? There's 3 doors. I've picked one of them. The chances are 1 in 3. Easy enough. Now, that means that there is a 2 in 3 chance of the diamond block being behind one of these 2 doors. When this third door is opened, the 2/3 chance is moved to this door. So basically now there's a 1/3 chance of the diamond block being behind that door, and a 2/3 chance of the diamond block being behind this door. And that is why actually switching your choice after you've made it is a much smarter decision. Now, most of you will probably be unconvinced by this logic. You'll probably say, well, no, there's a 1 in 2 chance now of the diamond block being behind either door. And I would agree with that logic at first, so that's why I'm going to give you another example. What if there were 100 doors? There are 100 doors here. You can count if you want to. I don't know how you would, but trust me, there are 100 doors. I spent quite a bit of time placing them all. And behind one of them is a diamond block, and behind all of the other 99 doors is a lever. Now let's imagine we're playing the same game. I'm going to pick a door from this massive array. Let's go this way a little bit, just a little bit, and I'm going to pick this door. Now, what Monty Hall is going to do is he's going to open every single other door but one. And if I was really lucky with my first choice, the door that has the diamond block is the first choice I made, all the way over there. However, if I wasn't quite so lucky, which I probably wasn't, the diamond block is behind another door, which is of course the only door that will be left unopened. So you can see that I'm opening all of these doors. Alright, that is 100 doors now opened. Well, 98 doors actually, because we have left 2 unopened, as you probably saw. We have left this door closed, and of course the door with my gold block closed. And now you can imagine that it probably makes more sense to switch to that unopened door, right? It just seems so much more unlikely that the diamond block is behind this one, which I originally chose. And of course, you'd be right to assume that, because if I open this door, there's a lever, whereas if I open this door over here, there's a diamond block. Ta-da! Now, this might make a little bit more sense to you, but I found that the explanation that made the most sense to me was when you go back to the original doors. Now let's say that the block of diamond is behind the second door. Now, let's go through the 3 scenarios one by one, alright? let's say first that I pick the first door. Monty Hall is going to open the third door because that is the one with the lever behind it. And if I switch, I get the diamond block, right? Because that's the way it works. I get the diamond block. Hooray, we're all happy. So if I pick the first door and then switch, I win. Alright, let's imagine now that I pick the second door. Now Monty Hall can open either the third door or the first door. Whichever one he picks, if I switch, so let's say he opens the first door, if I switch and I decide to open the third door instead, I will be wrong and I will get the lever, and I will be sorely disappointed. So, for the second door, if you switch, you lose. So we have a win for switch, a lose for switch, and now finally, let's imagine that I pick the third door. Now, of course, Monty Hall will open the first door, and if I switch my choice, then I will get the diamond block. So that means that if I switch, when I choose one of these two doors, I will get the diamond block. If I choose the middle one, I don't. So that means by switching, I have a 2 in 3 chance of getting my diamond block. And I will be happy. And I hope that made sense to you. If not, I'd recommend looking up some videos on it. It's really a cool problem in my opinion, and it kind of illustrates the fact that humans are kind of bad at probability if they don't think about it very much. Or at least I'm bad at probability because this took me a long time to figure out. I hope you enjoyed this, and I hope this made a little more sense to you, and if it does, and if you did, please leave a like because those doors took a long time to place. Man, don't you just hate levers? They're so useless.